Welcome back. This is How to Robot number 2, part number 2. I left off last time in a rather lousy place to stop because I simply ran out of time. First, we're going to get the bump sensors wired up. Then, we're going to get your computer set up for programming the Arduino and start writing our first program. So first we have to stop for a moment and talk about ones and zeros in a computer. Now, I don't know about you, but I've heard a lot that computers work in ones and zeros, meaning ons and offs. That's not really the case. It was back about 100 years ago when they used relays for computers. But since the advent of the vacuum tube and then the transistor in computers, we're actually using what they call high and low, meaning jumper wires always tangle. In the context of an Arduino and its input pins, a 0 is not off. It's not a disconnected pin. It is a low, meaning your input coming in, this wire is going to be the input coming into the Arduino, going into the Arduino, is actually connected to the negative side of your battery, the ground voltage level. And a 1 is when that wire, that pin going into the Arduino, is connected to the positive rail. And you have to do one or the other. If the pin is simply disconnected, it'll tend to kind of hold the state it was in last, a 1 or a 0, but not reliably. Because now that pin is connected to nothing, it's vulnerable to radio waves, Wi-Fi signals, magnets moving by it, and all those things can cause that pin to flip high or low. And so your readings won't be reliable. So the input from our bumper switches has to be a high or a low ground or 5 volts. We can't just let it float. Now there are better ways to do it than we're going to do it here, and that's namely what they call a pull-up or a pull-down resistor. But I wanted to reduce the number of parts we needed for this project as far as possible. So we're taking advantage of the fact that those limit switches are single pole, double throw. So let's talk about what that means. So here we have a functional drawing of a switch. And yeah, I think it's pretty clear. The electrical current comes in here, travels down the wire, goes into this moving part here, the lever, and it stops because, well, there's no connection here. Now, this movement, this piece right here moves. This movement is called the throw of the switch. This is a single throw switch. Now, the little contact points here on the end of this throw, make that a little bit bigger, throw, touching this, these are called the poles of the switch. So if I make this switch shut, there. Now the switch is closed. Now that can get confusing with switches and electronics, but yes, try to remember, in electrical stuff, closed means electricity goes through. Open means it doesn't. It's the opposite of a valve in a water pipe, which is kind of confusing. It even gets me sometimes, and I've done this for years. Anyway, now the current can flow through the switch, through the contacts here, and out the other side. Now that switch is turned on. That is a single pole, single throw switch. Now the switches we have are single pole, double throw switches. Let me show you what that means. Now this is a single pole, double throw switch. It's said to have 2 throws because it has a contact on one end of the throw and a contact on the other. So when you click that little switch, it flips this little contact from this upper contact point right here to the lower contact point down here. So when the button's pushed, you can see that the current can flow into the switch, through this contact point, and out this wire. But if the switch is released, the current flows into the switch, through the contact, or through the throw, or the lever, through these contacts, and out this wire instead. Now, we're going to flip that around. We're going to connect this pin here to the Arduino's input pin. And we're going to attach one of the contacts of that switch, the normally open contact, to the 5-volt power. Now the normally closed contact is going to be attached to the negative or ground. I can't write sideways very well. So what's going to happen is, when the bumper isn't pressed, the pin on the Arduino will be connected to the ground rail, giving it a low, an actual 0 in computer terms. But if the bumper gets pushed, the contact will move over to the normally open side, the one that's open when the switch is at rest. Now it's closed because the bumper's been hit. And that is connecting our input pin on the Arduino to 5 volts, and that will be a 1. So that's what it means when you see the NO marked on the body of the switch. That's the normally open contact, the one that will not conduct electricity through when the button is not pushed. Another pin that you'll see is marked NC. That is the normally closed pin. This pin will conduct through when the switch is not depressed. Now, this side of the switch right here, this pin that's always connected to the little lever down inside of it, that is just marked with a C for common. That is the common pin. It's always connected to this little lever that's doing its business in there. So let's wire them up. We'll be using those wires with the pins again. I've selected red and black, green and yellow, because that's what I had. Now we're going to be cutting one of the ends off the wire so that we have bare copper on one end and a pin on the other. And then we're going to cut a section of the red and a section of the black off. We need these to daisy chain the switches. So now we'll have our wires with a pin on one end and bare copper on the other. We'll start with the green and yellow wires and attach them to the common pins of the 2 micro switches. Strip back the wire the way I demonstrated in the previous episode, or use wire strippers if you have them. And now we're going to stick that wire through the hole in the pin on the micro switch and wrap it around itself. Make sure it's nice and tight. Now if I can get my camera to focus, you can see that's how it's supposed to look. Now soldering would be the right way to do this, but if you don't have a soldering iron, this will work just fine. We'll do the same thing with the yellow wire on the other switch. Put it through and wrap it around. Now for those red and black wires. Now I've twisted the short red wire to the long red wire, and we'll take that end that's all twisted together and put it through the hole and wrap it around itself as before. I'll take the other end of that short red wire and put it to the other switch on the normally open pin. Same method as before. We'll do exactly the same thing with the black wire. Through the hole, wrap it around, through the hole, wrap it around. Rinse and repeat, as they say. Now that's kind of a mess, but there we go. Beautiful. And we'll be gluing them down in place with hot glue, my favorite. Now it's time to wire the switches to the Arduino. We're going to start with the black ground wire to the normally connected pole of the switch and bring it to the GND pin on the Arduino. Ground. If you can see through all the camera shaking here. And now the red wire from the normally open contact will be wired to the 5-volt pin on the Arduino. This is actually a 5-volt output. Now we're going to wire the green and yellow pins. These are going to the I/O pins number 10 and 11. Those are the inputs we'll actually be reading. And after adding the ever-essential googly eyes, there it is in all of its glory. It's time to throw it against the wall and see if it sticks. Now let's get your computer set up. we're going to navigate to arduino.cc and we'll arrive at Arduino's homepage. It has many resources for Arduino creators, but we are going to need the software page. And here we are, Downloads, Arduino IDE. IDE stands for Integrated Development Environment. This is the program you use to program your Arduino. There's many options for installation, including ones for Windows, Linux, and Mac OS. There is even a web-based IDE for users of Chromebooks. We'll download the appropriate installer and run it and follow the directions provided. Now it's time to plug it in. My Arduino came with the appropriate USB cable, which is nice, but it's a bit short, so you'll have to see the top of my dusty computer. That's where I'll be setting the robot. Just plug it in and the Arduino will power up using the power from the USB cord. Now open up the Arduino IDE and you will see this. This is a completely blank program. Now there's a few housekeeping things we should do first. Go to File and Save As and save your project somewhere on your computer. Next we need to connect with the Arduino board. Go up to Tools and to the port. And here you will find the Arduino Uno on, well, this could be any port. On my computer it's COM7. It's already been selected because, well, I've already programmed this thing a little bit. Then go to the board menu and select Arduino AVR boards, and in this list find Arduino Uno, and that is the board we are using. With those selected, we're ready to jump into programming. But what on earth is all this garbly-gook we're seeing on the screen here in front of us? Now first, let's start with these lines with the slashes in front of them. Those are comments. Those aren't important to the computer. They are just to help you remember what you are doing there. You can write as many of these as you like, or as few. They don't matter as far as programming goes. Now in the interest of bringing this down to the simplest level, I'm going to get rid of these. We don't need that confusion in our lives right now. Now we've got these curly brackets. This is where they are is just fine, but I like to move them down below my function here. I simply find it easier to read, and I think it will be slightly easier to explain how they work. So this entire grouping is called a function. Everything in C-based languages, such as Arduino Sketch, use functions to get things done. Now, this keyword void, we won't pay attention to that right now. You won't need it. We'll get to that later. And setup is the function. Now, when you look at this, you might think, well, that looks a little bit like algebra, or using something such as the sine function in a calculator. This is exactly what it's structured like. We have the name of the function, and inside the parentheses are the parameters, the numbers that we will feed it. Now, this function doesn't have any parameters. You need to have these brackets here anyway. The function setup is the boot cycle, you might say, of the Arduino. This function gets called first when the Arduino starts up, and it runs through once. Now these curly brackets here, what they mean is everything in between these curly brackets are part of the function setup. And we will put our lines of code in between these brackets, and they will execute from top to bottom. The first thing we need to do is set which pins are outputs and which pins are inputs. Right now we are writing inside of a function, but we'll be doing that by using functions. And the first function we're going to use is called pin mode. Now we get this little tooltip that pops up, and it's got lots of garbly-gook
uint8_t pin, uint8_t mode.
We'll probably talk about that in a later video, but what's really going on here is it says that you need the pin, then a comma, and then the mode. Now, looking on my handy-dandy cheat sheet, it looks like right forward is pin 3. So, pin 3, comma, and then the mode of the pin will be output. Now, this capitalized output is what they call a constant. It's a word that when the compiler goes through, it just converts it straight to a number. You could simply write a number into this section, but you'd have to remember which number stands for an output. Now, to make the computer execute this function, you need to put down a semicolon. Now, to compare it to the English language, the semicolon is like a period. It is the end of a statement. And I will add a comment to remind us what on earth this is. 2 slashes, so now everything behind these slashes will be ignored. Now I will do the same for the other 3 wires that control the motor controller. Now we have the 2 bumper switches, which are inputs. So what this will do, the Arduino will call the setup function, and it's going to go through and execute these lines one at a time, setting each input and output. Once it gets down to here, it's got nothing more to do. And so the Arduino will now go down to the loop function. Now this loop function behaves exactly the same as the setup function, with one exception. It runs over and over and over and over. It will execute all of the instructions in a row, and when it finishes and gets down to the bottom, it will loop back around to the top and start all over again. Let's write our first very simple program now. We're going to use another function now, and this is called digital write, and this will write a 1 or a 0 to the pin selected. Notice the capitalization in these functions. Capitalization is very important in C. If you have a lowercase letter where you should have an uppercase letter, it will fail. You must have the capitalization correct. I'm going to write to pin 3, which is the right motor in the forward direction, and I will write a 1. Put down my semicolon because that is a complete statement. Now I'm going to use another function called delay. Open my brackets to put the parameters in. This will make the entire program pause for a certain amount of time, and this amount of time is in milliseconds, so 1/1000ths of a second. I will make the program stop for 1 second right here with the motor going forward. Now I will use the digital write function again to turn that motor off. Number 0 will be off, and I will add delay again to make sure that that motor stays off for 1 second. And there is our first program. I recommend putting something underneath the robot to make sure the wheels can spin without it trying to drive away with the cord still attached. Then go ahead and put the batteries in place. Now we're going to go up to the upper left-hand corner and hit the little upload arrow. Your program should immediately start uploading to the Arduino. You'll see a whole bunch of technical looking jargon flash by on a black screen that just appeared at the bottom, and there we go. The right motor on the robot will start running and stopping, running and stopping. You've done it, your first Arduino program. So we've essentially made the right motor of the robot blink. It's turning on and off. That's great. But the magic isn't quite in it yet. The magic comes through the if statement, a conditional set of instructions. Let me reconfigure the code here a little bit and add some comments for clarity. Now we're going to start by making both motors go forward. Our forward pins, according to my cheat sheet, are pin 3 and pin 9. And we will make pin 9's value a 1, and I'll add some comments for clarity. Let's make sure that our reverse pins are 0s. We don't want the motors to try to go in forward and reverse at the same time. On my cheat sheet, pin 5 is right reverse, and pin 6 is left reverse. There. That will make the motors go forward, and at the moment they'll go forward all the time. Here comes that if statement. We're going to write if, and open our parentheses. Now inside of these parentheses, behind an if statement, we're going to make a statement that can be evaluated to either true or false. But the very first thing we need it to do is get the value of one of our bumpers. I'm going to use pin 10, which is the left bumper. So now the function we will use is called digital read. Open our parentheses for the parameters, and it only has one parameter, and that is the pin number. According to my cheat sheet, pin 10 is the left bumper. Now, just like you would see in algebra, this function is actually equal to a value. Whatever the value of pin 10 is, that will be the value of digital read in this little expression. Now, we're going to compare it to another value, a 1. We'll use double equals. Here's another funny thing about programming. In most programming languages that I've ever worked in, the double equals sign is a comparison, whereas a single equals sign will set a value. If I say if digital read pin 10 equals 1, this will attempt to set the value of digital read to 1, and that's going to be a problem. If this were a variable, it would successfully set its value to 1, and so this statement would always evaluate true. We will use the double equals, which is a comparison. Now it will compare the value returned by digital read to a 1 and evaluate to true or false. If it's true, it will now execute the code between these new curly brackets directly after the if statement. Here is where we'll write our code that will happen if the bumper is pushed. Now I'm going to invoke the magic of copy and paste and take all of these motor control lines and put them down here. Now when you start writing your own functions, it would be great to group these into a function and call it go forward. But today I'm trying to keep it as simple as possible and easy to follow the way the program runs. And so we're going about it the long way around. So first, I'm going to make the robot back up. I will set the forward pins on the motors to 0 and the reverse pins on the motors to 1. We have to put in a delay, so the program will stop and wait 1 second while the robot reverses. Now I will make the robot turn. I will use that same block of code again, but this time, since it's the left bumper getting hit, I want the robot to turn right. To do that, the left motor will go forward, so I will change its forward pin to a 1, and I will change the reverse pin on the left motor to a 0, so it's not trying to go 2 directions at once. Now, the left motor will be going forward, and the right motor will be going in reverse. And we have to make the program stop again and wait for that action to happen. It will turn for 1 second and finish the if statement, and it will continue down here. Now, of course, there's no other instructions down here, so the Arduino will go back up to the top here of the loop statement and run through it again. I will then use my favorite keys on the keyboard once again and copy and paste this entire if statement. And now I will modify it to work for the other bumper. The right bumper is pin 11. If pin 11 is a 1, it will reverse and do that for 1 second. Then I'm going to flip around the direction that it turns. Since it's the right bumper, I want it to turn left. Right motor forward pin to a 1. The left motor forward pin to a 0. The right motor reverse pin to a 0. We don't want it going 2 directions at once. And the left motor reverse pin to a 1. Now it will only execute these lines of code if this statement here is true. Otherwise, the program will simply jump right over it. And this should be our very first autonomous program. Let's find out. I'll hit the program button. And it works. Let's put it on the floor and watch it go. And there you have it. This is the end of How to Robot number 2. I hope you've enjoyed it. I hope you found it helpful and you've gotten a start with robotics. I'm not an expert programmer. I highly recommend that you look at other Arduino programming tutorials. I'm largely self-taught, and so I probably have bad habits and some wrong concepts, but I can make it work, and that's where I wanted to get you. I do intend to continue my How to Robot series. There's other things I want to cover, the basics of machine learning, machine vision, things like that. But for my next video, I'm going to change course a little bit again and cover other projects. I'm hoping for a nice update for my household robot, Gort, but we'll see. So with that, please like and subscribe, it helps a lot, and I hope to see you next time. Until then, I'm Joe, signing off.